The cliffs of the Great Australian Bight hide one of the strangest geological mysteries in Australia. Beneath the Southern Ocean lies a sedimentary basin more than 15 kilometres deep, filled with ancient river deltas buried since the age of the dinosaurs. Some geologists believe the rocks down there contain all the ingredients needed for a giant oil province, the kind that can reshape economies. Oil companies spent decades and billions of dollars trying to find it. BP, Chevron, Equinor, some of the largest petroleum companies on Earth all arrived here, chasing the same possibility. And yet, after drilling some of the deepest offshore wells in Australian history, they left empty-handed. But the strange part is this: many geologists still believe they may have simply missed the right spot. For most people, the Great Australian Bight looks empty, a vast curve of coastline where towering limestone cliffs meet one of the roughest oceans on Earth. But beneath those waters is an entirely different world. Hidden below kilometres of ocean and sediment is a gigantic buried basin created during the breakup of Gondwana, when Australia finally tore away from Antarctica. Around 100 million years ago, southern Australia looked nothing like it does today. Antarctica was still attached to the continent, and enormous river systems flowed across a cold polar landscape into a growing rift valley along the southern margin. As the crust stretched and thinned, the land began to sink. Huge depressions formed offshore, creating space for unimaginable quantities of sediment to accumulate. Those rivers dumped sand, mud, and organic material into the basin for millions of years. Entire delta systems began stacking on top of each other, slowly sinking deeper as the crust continued subsiding beneath them. Over time, thousands of meters of additional sediment buried the older layers below. Pressure increased, temperatures rose, organic material trapped within the rocks began transforming into hydrocarbons. This is the process that created many of the world's great petroleum provinces, and that is exactly why the Great Australian Bight became so interesting to oil companies. The geology of the Bight Basin began attracting serious attention in the late 20th century as seismic surveys revealed the true scale of what lay beneath the Southern Ocean. The Ceduna Sub-basin in particular stunned geologists. In some areas, the sediment pile exceeded 15 kilometres thick. That is enormous, comparable to major hydrocarbon basins elsewhere in the world. What made it even more intriguing was the basin's age and structure. The buried Cretaceous delta systems resembled the kinds of depositional environments associated with giant petroleum provinces overseas. Thick marine sediments, deep burial, rift-related subsidence, potential source rocks, potential reservoir sandstones, structural traps. On paper, many of the ingredients appeared to be there. The problem was proving it. Oil exploration in the Bight has always been difficult because this is not a normal offshore basin. The Southern Ocean is violent. Waves routinely exceed 10 meters. Storm systems move across the region with extraordinary force. The basin itself lies in extremely deep water, often over 2 kilometers deep before drilling even begins penetrating the seabed. That makes every exploration well astonishingly expensive. Unlike shallow offshore basins where companies can drill many wells relatively cheaply, each deepwater well in the Bight can cost hundreds of millions of dollars. A single failed hole can destroy an exploration campaign. Despite the risks, companies kept arriving. Early exploration began in the 1960s and 70s, when the first seismic surveys and exploratory wells were drilled offshore. Those early programs confirmed that the basin was real and deeply buried, but they failed to discover commercial accumulations of oil or gas. Interest faded temporarily, only to return decades later as offshore drilling technology improved. By the 2000s, the Great Australian Bight had become one of the most closely watched frontier basins in the world. Some geologists began comparing the Ceduna Sub-basin to major Atlantic margin petroleum systems. Others believed the buried delta sequences could rival giant oil provinces if hydrocarbons had accumulated correctly. The possibility was enough to attract some of the largest petroleum companies on Earth. BP became the most famous. In the mid-2010s, the company acquired exploration permits covering enormous areas of the Bight and proposed drilling ultra-deep water wells using the Ocean Great White drilling rig. These were not shallow coastal wells. BP planned to drill through kilometres of ocean into deeply buried Cretaceous sediments far beneath the seafloor. The scale of the operation was immense. Chevron also acquired acreage in the basin. So did Norwegian energy company Equinor. Santos held interests as well. Billions of dollars flowed into seismic acquisition, geological modelling, environmental studies and offshore planning. And yet, despite all that effort, no major commercial discovery was ever made. At least not yet. This is where the story becomes genuinely fascinating. Most failed exploration basins lose industry interest quickly, but the Bight has always been different because many petroleum geologists never stopped believing the system itself was valid. The problem may simply be that nobody has drilled the right structure. That sounds unbelievable until you realise how petroleum exploration actually works. Oil basins are not uniformly filled with hydrocarbons. A basin can contain all the ingredients needed for oil generation while still producing mostly dry holes. Hydrocarbons must migrate into the correct reservoirs. Those reservoirs need adequate porosity. Structural traps must remain sealed for tens of millions of years. Timing matters, burial history matters, even tiny geological differences can determine whether a well strikes a giant oil accumulation or barren rock. Some of the world's greatest oil provinces looked unsuccessful for decades before one discovery changed everything. Offshore Guyana is one of the best examples. Companies drilled unsuccessful wells there for years. Many assumed the basin was uneconomic. Then ExxonMobil struck the Liza discovery in 2015, revealing one of the largest oil finds of the 21st century. Suddenly, an overlooked frontier basin became one of the hottest petroleum provinces on Earth. That possibility still hangs over the Great Australian Bight, because despite the lack of commercial discoveries, the geological evidence never fully disappeared. Some exploration wells encountered hydrocarbon shows, others identified source rocks capable of generating oil and gas. Seismic data continued revealing enormous buried structures beneath the basin. The deeper researchers looked, the more they realised how little of the region had actually been tested. The Bight remains astonishingly underexplored compared to most producing offshore basins. That is partly because exploration became trapped between geology, economics, and politics. The technical challenges alone are extreme. Deepwater drilling in the Southern Ocean is among the hardest offshore operations anywhere on Earth. The weather window is narrow. Equipment costs are enormous. Logistics are difficult due to the basin's remoteness. Any large-scale development would require billions more in infrastructure investment. Then came the environmental concerns. The Great Australian Bight is one of Australia's most ecologically sensitive marine regions. Whales migrate through the area. Marine ecosystems along the Bight are unique and highly productive. Opposition to offshore drilling intensified rapidly during BP's exploration campaign, with fears that an oil spill in such remote and hostile conditions could be catastrophic. Public pressure grew, regulatory scrutiny intensified, and political debate escalated. Then economics changed everything. Global oil prices weakened, exploration priorities shifted, and the cost of drilling in the Bight became increasingly difficult to justify compared to proven petroleum provinces elsewhere in the world. In 2016, BP withdrew from the project. Chevron later exited as well. Equinor eventually abandoned its plans in 2020 despite receiving environmental approval to drill. To many people, that looked like the end of the story. But geologically it may not be, because the rocks beneath the Bight have not disappeared. The buried delta systems are still there. The rift basin is still there. The thick sedimentary sequences are still there. And so is the possibility that somewhere beneath the Southern Ocean, hydrocarbons accumulated in the right structure at the right time. That uncertainty is what makes the Great Australian Bight so unusual. Most frontier basins fail because the geology is poor. The Bight is different, because many of the geological ingredients appear surprisingly favourable. The uncertainty comes from the fact that so little of the basin has been drilled relative to its enormous size. In other words, the absence of a discovery may not prove the system is barren. It may simply prove that finding oil in a basin this large is extraordinarily difficult. And history shows that giant discoveries often happen exactly like this. One successful well can completely redefine an entire basin. If a major accumulation were ever discovered beneath the Great Australian Bight, it would instantly become one of the most significant petroleum discoveries in Australian history. Exploration would surge back into the basin almost overnight. Infrastructure proposals would reappear. Global energy companies would return. And one of the world's most mysterious offshore basins would suddenly transform from a geological theory into a proven petroleum province. Or perhaps the opposite is true. Perhaps the basin only imitates the appearance of a great oil province without ever fully becoming one. Perhaps the source rocks were never rich enough. Perhaps the hydrocarbons escaped millions of years ago. And perhaps the traps failed long before modern oceans formed above them. Right now, nobody truly knows. And that is why the Great Australian Bight remains one of the most fascinating geological mysteries beneath Australia. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.